So good morning from me also, I'm Marcus Duskos, and I will briefly present the services belong to the underwater thematic area. So just to give some perspective, sensing, mapping and reconstruction are some main tasks for when we deal with the underwater environment, and they are quite demanding and pose some significant challenges, both scientific and technological. So this is because both due to the vast of the ocean and the harsh conditions, and also the way that the main means in which we collect information, like the sound and the light, have some particular properties in the water to account for them. The main sensors we consider usually for addressing this task are both active, like multi-beam sounders, and passive, like normal cameras or some cameras with some special characteristics. And these sensors are deployed both from ships but also underwater from ROVs or autonomous vehicles. And usually the task that of main interest is to know the bathymetry of the area that is surveyed, to have some map of the seafloor, and to also classify the seabed. And these are exactly the tasks that our services in the underwater thematic area, the service of NEANIAS are addressing, and through some user-friendly cloud-based solutions. So first of all, regarding the first underwater service, it's called CWs Market for short, or bathymetry mapping service, and it provides a user-friendly way to interact with a well-known open source system, the so-called system software, that's specialized for post-processing data collected during underwater surveys from multi-beam sounders. And the goal is to post-process this data in order to produce digital terrain models and also backscatter images of the seabed. So this is, in this slide, we briefly summarize the purpose of the service. It's an easy to access source of file that's based on Linux, and not specifically on the end system, as I said. It reads and can deal with many different vendors, the vendor-specific and generic formats of coming from multi-beam sounders, and it's able to produce both bathymetric and backscatter products based on this data. And also you can output the results in many standard formats, including JPEGs, CDF, and so on, that can be processed later on in some user-specific pipelines. The second service regards images from RGB cameras. It's called seafloor mosaicing, or PWMOS for short. And it is both in a way that it has many sub-services that deal with specific subtasks regarding the processing of the underwater images, including camera calibration, image quality check, correction of the colors of the images, because these are heavily affected in the underwater environment from the presence of water. And then the main results are the 2D mosaics, which are like 2D maps, symmetric maps, on top of which we can measure distances and whatever other information we want to collect. And also 3D, the service produces 3D reconstructions of the seabed, which are much more detailed regarding the bathymetric data we collect from the samples. So the purpose is to create, as I said, 2D and 3D maps from the images. The inputs is a set of images collected by the user during a survey mission. Usually this is a quite large number of images, and this service is able to deal with this big amount of data. And the outputs are either 2D mosaics, or both 2D mosaics and 3D mosaics of the surveyed area. This is based on the Colonists in-house solution in C++, and some open source libraries for computer vision applications. This service has been tested thoroughly from our partners in the University of Marseille during the normal operations in surveying some archaeological sites, like in this case the port of Aegium. against the harbor fencing. Now for the third service, it's about seabed classification, and the short name is CWs Market. And this service is responsible for providing classification maps of the seabed, given data collected from multi-frequency, multi-beam echo sounders, which are some relatively new sensors that acquire information, backscatter information, not from only one frequency, but from multiple frequencies, which is helpful for being able to better differentiate between different sediment types. So the main idea is that providing the backscatter images, which has now multiple channels because we talk about multiple frequencies, we have built the classification models and for some specific classes of categories of seabed, geological sense, and the output of the service is the classification map for each position of the image. You get a class defining what is the category of the seabed of this specific position, and also this service has been assessed and used by our partners for archaeological targets and also geological and other targets in the seabed. So that's all for the underwater services. Thank you.